Hello and welcome. We completed the previous lecture with the DevOps Buddy application running on a single availability zone. This consisted of having only one Apache HTTPD server and one Spring Boot server. In this lecture, we will be preparing the ground for autoscaling and elastic load balancing. In particular, we will create an Amazon machine image, commonly referred to as AMI, from the Spring Boot instance. See how to run a bash script when an instance starts up. Spin up two Spring Boot instances from the AMI. Create an internally facing load balancer for the Spring Boot instances. Modify the Apache HTTPD configuration so that the proxy configuration points to the newly created internal load balancer. Create an AMI from the Apache HTTPD server. Spin up the Apache HTTPD instances from the newly created AMI. Create a publicly facing load balancer to put in front of the HTTPD servers. And finally, set the sticky sessions for the internal facing load balancers and testing the application by invoking the load balancer URL. Please be warned that the use of load balancers incurs a small cost. For more details, please search for AWS load balancer pricing. An AMI is a machine image that can be used to spin up an instance which is identical to the one from which the AMI was created. AMIs are fundamental to the autoscaling and load balancing concepts. I define them as the atomic bootable units for highly available and highly scalable architectures on the AWS platform. The first thing we'll need to do is to create an AMI from the currently running Spring Boot instance. To do this, right-click on the Spring Boot instance and select Image, Create Image. As image name and description, we can give the value Spring Boot AMI. The No Reboot checkbox is quite important. If you don't select it, once you click on the Create Image button, AWS will shut down the instance before creating the AMI, and then we restart it. Otherwise, it will create the AMI while the instance is running. I tend to always check this box. Once ready, click the Create Image button. It will take a few minutes for the AMI to be available, therefore I'm going to pause the video and we'll resume once done. Now that the AMI has been created, we can terminate the current Spring Boot instance, create two Spring Boot instances from the AMI, one in each of the availability zones from our architectural diagram. I'll show you how to do this for one instance, and then, as an exercise, I'd like you to spin up the second instance in the other availability zone. To launch an instance from an AMI, right-click on the AMI and select Launch. Then, select T2.micro as type, DevOps Buddy as VPC, one of the Spring Boot subnets, I'll choose EU West 1A, disable auto-assign public IP, and select DevOps Buddy -full as a role. Now, I'll show you how to execute a bash script when an instance starts up. I've attached this file to the lecture as a Spring Boot AMI init.sh. Basically, when the box starts up, we want to update the operating system with the latest libraries and make sure that the Spring Boot application starts up. If you look towards the bottom of the screen, you will see an Advanced Details section. If you expand that, you will find the three options: as text, as file, input is already base64 encoded. Don't worry about the last option, as it's unlikely that you will be using it often, if at all. The first option means run whatever bash commands are written within the text area. With the second option, we can provide a file to execute. I'll go ahead and copy the content of the Spring Boot AMI init.sh script in the text area. The first line is normally known as #bang. It's a directive that instructs the runtime that this is a bash script by providing the full path to the bash executable. We then execute the instruction sudo yum update -y to update the operating system. Finally, we execute the command sudo service DevOps Buddy restart. When AWS starts the Spring Boot instance, it will execute the commands that we have just declared. Once done, you can then click Next twice. As name tag, we can enter Spring Boot Server. We will also add the visibility tag with value private. Then click Next again and select the Spring Boot security group and click Review and Launch. Keep accepting the defaults until you launch the instance. Once done, pause this video and repeat the process by spinning up another Spring Boot instance, only this time choosing the second availability zone from our architectural diagram. I will choose the Spring Boot subnet with the EU West 1C availability zone. I'm now going to pause the video until I've spinned up the second instance, as this process might take a few minutes. Once done, you should have 2 Spring Boot servers running, each one in a different availability zone. Great work! Now, we will need to make a change to the Spring Boot security group in preparation of our next step, which will be to create an internal load balancer. If you remember from a previous lecture, we have set this security group to accept traffic on port 8080 only from the public security group. Since we will soon be creating an internal load balancer to front the 2 Spring Boot boxes, and this load balancer will ping the 2 servers on port 8080, we need to change the source for the inbound port 8080 to be the entire VPC, which is the CIDR address 10.0.0.0/16. We will also create a new security group for the internal load balancer with one inbound rule: port 80 accepting traffic from the entire VPC. Similarly, we will create a new security group for the publicly facing load balancer with a single inbound rule for port 80 from anywhere. As a reminder, we set the CIDR value to 0.0.0.0/0 to specify anywhere. Now we are ready to create the internally facing load balancer. From the EC2 dashboard, click Load Balancers and then Create Load Balancer. As name, we will call it Spring-Boot-LB with LB in uppercase, and we will make sure to select the DevOps Buddy VPC. We will also make sure to tick the Create an Internal Load Balancer checkbox to make sure this is not reachable from the internet. Next, we will leave the load balancer port to 80. However, we will set the instance port to 8080. Think a moment about this. The Apache HTTPD server will proxy requests to the internal load balancer on port 80, which in turn will forward requests to any of the Spring Boot boxes on port 8080. Finally, at the bottom of the page, make sure to select the 2 Spring Boot availability zones by clicking on the plus button. This is how the load balancer knows which availability zones to monitor. Click Next and select the internal load balancer security group that we have just created. Once done, click Next until you get to the health check configuration. As ping path, we will simply specify /, which indicates the root context. We will specify the value 5 for both unhealthy and healthy threshold values. Once done, click Next. In this screen, we will select the 2 Spring Boot boxes that we have spun up from the Spring Boot MI. Make sure that the Enable Cross-Zone Load Balancing and the Enable Connection Draining checkboxes are selected, and specify 100 seconds in the text field. Once done, click on Next. Here, we can add a type tag with the value load balancer and click Review and Create. Once done, click on the Load Balancer dashboard and then on the Instances tab. It will take a few minutes for the load balancer to flag the 2 instances as in service. Currently, you should see the 2 instances marked as out of service. If after a few minutes the instances are not flagged as in service, you can double check that the DevOps Buddy application is working on both Spring Boot boxes. To do this, you will first need to log in into the Bastion host with the /-A command, and from there to the private IPs of the Spring Boot boxes. Then you can invoke the command curl http localhost 8080. The output should show the content of the index.html page coming back. If not, restart the DevOps Buddy application with the command sudo service DevOps Buddy restart. As a reminder, the DevOps Buddy logs are available in the ~logs/DevOps Buddy folder. I'm now going to pause the video until the two instances have been marked as in service. Great! Now that we have the two instances registered with the load balancer, we need to update the Apache HTTPD proxy configuration. To do this, we can SSH into the Apache HTTPD box using the public IP address. Copy the internal load balancer DNS name. You can find this in the description tab of the load balancers menu in the AWS console. Its name probably starts with internal hyphen and ends with elb-amazon-aws.com. On the Apache box, edit the httpd.conf file with the command sudo vim/etc/httpd/conf/httpd.conf. At the bottom of the file, where we have set the proxy configuration, we need to replace the private IP address for the Spring Boot box with the internal load balancer DNS name without any ports, meaning that we will hit the load balancer on port 80. Once done, we will need to restart the Apache HTTPD server with the command sudo service httpd restart. Now, we can test that our Apache HTTPD server runs correctly. Pointing our browser to the Apache server public IP address, we should see the DevOps Buddy homepage coming back. Great work! This means that our Apache HTTPD server works fine and is configured correctly. We can now create an AMI from the Apache HTTPD server. As before, from the EC2 dashboard, we can right-click on the Apache HTTPD instance and select Image Create Image. We can set the name and description as Apache HTTPD AMI. Let's remember to tick the No Reboot checkbox and select Create Image. I'm now going to pause the video until the AMI has been created. OK, now that the AMI is available, we can terminate the current Apache HTTPD box and spin two new boxes from the AMI, one in each availability zone. I'll set the first one up. Then, as an exercise, I'd like you to set the other one up in the other availability zone. Right-click on the Apache AMI and select Launch. Select t2.micro as instance type and click Next. Select DevOps Buddy as VPC and then one of the two public subnets. I'll choose EU West 1A. Select Enable as Auto-Assign IP Configuration and DevOps Buddy -full as IAM role. Now, we will execute few bash commands when a box starts up. I've created the file apache httpd mi init.sh and attached it to this lecture, and I'm now going to copy its content to the text area. This script is very similar to the previous one. We update the operating system with the command sudo yum update -y. This time, we make sure that the Apache HTTPD server is up with the command sudo service httpd restart. Please pause the video and make sure that your copy looks exactly like the one that you see on the screen. When done, click Next twice. As name, we will set the value Apache HTTPD server. We will also add a visibility tag with value public. When done, click Next. We will set the public security group and click Review and Launch. Finally, follow all steps until this instance is up and running. When done, you can verify that it works by pointing a browser to its public IP address. The DevOps Buddy homepage should appear. Great work! Now, we can point an Apache HTTPD instance to an internal load balancer, which in turn forwards requests to one of the two Spring Boot boxes running the DevOps Buddy application. You can go ahead and spin the other Apache HTTPD instance from the AMI, making sure that this time you select the other availability zone. For me, this will be EU West 1C. I'm now going to pause the video so that I can create the second instance, and will resume when done. Great! Now that we have two Apache HTTPD servers running, we want to create a publicly facing load balancer to put in front of them. To do this, click on the Load Balancers menu and then on the Create Load Balancer button. We will call the load balancer public-lb with LB in capital letters and select DevOps Buddy as VPC. This time, we want to make sure to untick the Create an internal load balancer checkbox, because we want this one to be accessible from the internet. We will leave the load balancer ports as they are now. Then, we will select the two public subnets, in my case EU West 1A and EU West 1C, by clicking on the plus button and then on Next. We will then select the public load balancer security group and click Next. Again, for the health check, we will simply check the root context and set the unhealthy and healthy threshold to be 5. As for the instances, we will select the two Apache HTTPD servers and click Next. As type tag, we can set load balancer. Review all your choices and finally click on the Create button. Similarly to what happened with the internal load balancer, it will take a few minutes for the two Apache HTTPD servers to be considered healthy. I'm now going to pause the video until this happens. Now that the two instances are in service, we can test the DevOps Buddy application homepage comes up when we hit the public load balancer DNS name. As a reminder, the DNS name can be found in the description tab of the load balancers menu. You can copy the address and open a browser window pointing at it on port 80, therefore don't mention the port in the URL. Great! The DevOps Buddy application homepage comes up. However, we do have a problem. If you try to log in with the admin username and password, it's likely that you will get an error with status 403 and the message expected CSRF token not found. What happened here? Since the load balancer balances requests between the two Apache HTTP boxes and they in turn hit the internal load balancer, which dispatches them to one of the two Spring Boot boxes, when we first hit the login link, the login form was created with a CSRF value generated by one of the two servers. Once we submitted our authentication information though, the request might have gone to the other server, which did not recognize the CSRF value, hence the error. To solve this problem, we need to introduce session stickiness in the internal load balancer. We can click on the load balancers link and then on the internal load balancer. In the bottom half of the page, you will see a section called Port Configuration. If you look at it carefully, you will see a value stickiness :disabled with an edit link. Click on the edit link. AWS shows three options: disabled, load balancer generated cookie stickiness, and application generated cookie stickiness. Each Spring Boot application sets a JSessionID cookie to help with session stickiness, and DevOps Buddy is no exception. So, we will check the Enable Application Generated Cookie Stickiness and enter JSessionID all in uppercase as cookie name. Make sure that you spell it as shown in the video, all in uppercase letters. Then, we will click on the Save button. If you now try to hit the load balancer at the root context again and follow the login journey, you should be able to log in. Another way to bypass this problem is of course to disable CSRF in the security configuration class. However, CSRF is a good thing to have and we should strive to keep it, especially if this has to become one of our production applications. With this test, we end this lecture. We now have two load balancers, one publicly facing and one internally facing. The public load balancer forwards requests to Apache HTTPD servers, while the internal load balancer forwards requests to the Spring Boot servers. We also have two AMI types, one for Apache HTTPD and one for Spring Boot. We will reuse them in the next lecture when we will be setting up auto-scaling and elastic load balancing. Thank you for your time, and I see you in the next lecture.